interact with society. Donald is an industry leader in societal context understanding, machine learning, fairness, and ethical artificial intelligence research. And he's super passionate about combining community-based participatory and dynamical systems methods to foster more equitable, safe, and robust AI-based products. He holds a BS in electrical engineering and has over 30 years of technology leadership experience. He has held CIO, CTO, COOs, probably some other C and O combinations of positions, as well as product manager positions at global software development companies and telecommunications service providers. Donald holds a US utility patent for problem modeling and resource optimization. His most recent publication in the Harvard Business Review article is entitled AI Engineers Need to Think Beyond Engineering. So I really look forward to his presentation, and he's going to really challenge us to think beyond. Donald, welcome.
Thank you, Talitha. Hello, everyone. It's really an honor and a pleasure to be here today. Let me share my screen. Is that working yet? Screen presenting? Yes.
Yep, perfect.
So like I said, it's an honor and pleasure to be here today. The title of my talk is Prototyping Problems to Bridge the AI Problem Understanding Chasm and Foster Responsible, Robust AI. And as Talitha said, I'm the head of Societal Context Understanding Tools and Solutions. Our mission is to empower people with the scalable, trustworthy societal context knowledge that we think is required to realize responsible, robust AI and to solve the world's most complex societal problems. Now, we also think that bridging the AI problem understanding chasm, which I'm going to introduce in a little bit, is key to us being able to realize our mission. So we've recently kicked off a campaign to amplify how many people are spending time thinking about and working on solving this problem. So we have something we call our flywheel, which we're using to get this process going. The first thing we're doing is increasing awareness about the problem understanding chasm, giving talks, writing publications. This talk is part of that first part of the flywheel. We hope that leads to more foundational and applied research around the problem understanding chasm, particularly with respect to causal theory modeling. And then we hope that leads to real world impact, which will of course drive more awareness. Now, the use case area that we focus on is AI health equity. Now, before I dive into the core of the talk, I want to set a little bit of context. I think everyone realizes right now we're at a serious transformational moment in society. And it's clear that the key technology of that industrial revolution, which is the fourth industrial revolution happening right now, a lot of people think this transformation is the fourth industrial revolution. AI is the key technology of that. And so we have big hopes that AI is going to change and transform things like medicine, healthcare forever. But we also are very cautious because of that elephant in the room, harmful bias that can creep into these systems very easily. And so it's part of my job to pay attention to all the headlines that come out every day about instances of bias in systems across many different sectors. But I pay particular attention when those headlines have to do with medical care or healthcare. And that's because of my mom, Betty Martin. She passed away 5 years ago this month from cancer. And I was with her on that journey, and I saw firsthand how she had to deal with bias in the healthcare system. And so that experience informs how I think about how to mitigate bias in AI systems applied in high stakes domains. Now, like I said, my mom died from cancer, started off as breast cancer, evolved to lung cancer. And at some point she had to have part of one of her lungs removed. And that led to her developing something called atrial fibrillation. And that can lead to blood clots and to stroke. So her doctor had to prescribe her a blood thinner. But the blood thinner that the doctor prescribed would have required her to drastically change her diet. She would have had to eliminate vitamin K foods. These are leafy greens like spinach and kale and collard greens. These are really a core part of my mom's diet. She loved leafy greens. She would also have had to go to the hospital every week to have her blood checked to make sure this drug wasn't harming her. So it had some side effects. So when my mom heard these requirements, she balked and she said, "Are you sure there's not another alternative? I'd rather not have to make those changes while I'm going through all these other things if I don't have to." The doctor's response was, "You really shouldn't complain. You should feel lucky because people from third world countries would be grateful just to have access to this drug." My mom was like, "Okay, I'm not sure what that has to do with me." And of course, you all don't know my mom, but she didn't accept the doctor's answer. She talked to me and my sister and my dad. My sister happens to be a medical doctor, a psychiatrist. So she was able to quickly find an alternative blood thinner that didn't have any of these side effects. So we went back to the doctor and we said, "Hey, we found an alternative blood thinner. It doesn't have these side effects, but we want to make sure we're not missing something. Can you tell us why you didn't prescribe this better blood thinner without the side effects in the first place?" And the doctor's response was, "I assumed that she would not be able to afford the alternative." Let me say that again. "I assumed she would not be able to afford the alternative." So this is bias rearing its ugly head in the middle of this situation. The assumption that the doctor made abstracted away and ignored my mother's situation, her circumstances, what I'll call her societal context. So let's walk through my mother's societal context visually. And there's my mom. As I said, she loved leafy greens. This was her second bout with cancer. So she already had this experience of having to go to the hospital every week for chemotherapy, get stuck with a needle, feeling horrible. So she tried to avoid that sort of experience anytime she could. Loving family that she has, that includes my sister, like I said, who's a medical doctor, a psychiatrist, very good at navigating the drug industry. She has my dad, who's a double retiree from the US Postal Service and the US Army. So we had great healthcare insurance. So it was really easy for us to have an alternative. But the doctor abstracted away, ignored all of that societal context. And they came up with an intervention that conflicted with that societal context and could have led to harm for my mom, right? That drug had side effects. So here's the definition of societal context. It is the dynamic collection of the complex issues such as social, cultural, historical, political, and economic circumstances that surround people, places, and things. So we're going to be talking about societal context quite a bit. Now, the key takeaway from my mom's experience, and I think the key takeaway for this overall talk, if you don't take away anything else, please remember that interventions that ignore or abstract away societal context can lead to unintended and unnecessary harm. Now let's dive into the core agenda. First, I'm going to talk about how we abstract away societal context when we develop machine learning and AI systems. Then I'm going to introduce the problem understanding chasm through an example of racial bias in a medical algorithm. Then we're going to talk about community-based system dynamics, which we think is a method to help bridge the problem understanding chasm. It's a way for prototyping problems and producing societal context knowledge. And then finally, we're going to talk about building community capability in prototyping problems. So I'm going to walk through a high-level overview of a typical AI product development lifecycle. Key thing to remember is these life cycles are driven by human decision-making from end to end. And the sorts of decision makers are people like product managers, user experience researchers, research scientists, and software engineers. And the whole point of this life cycle is to produce a machine learning or AI model that can be the basis for a product. And this model will generate outputs, typically predictions that can be used to automate decision-making and to help solve problems. Now, in order to produce that model, we have to train, tune, and evaluate it. In order to train the model, we have to select and prepare training data. In order to select and prepare that training data, we have to formulate the problem we want to solve for machine learning and AI. You can think of machine learning and AI as the hammer that we have. We have to make the problem that we want to solve look like a nail. And then in order to do that, we have to understand the problem deeply. And of course, this whole life cycle is driven by observations and data. Now, we don't often talk about where those observations and data come from, but they come from this thing we're calling societal context. Now, when we do machine learning fairness work, we also refer to societal context as the social technical environment. Computer scientists and machine learning practitioners, they have many different words that they use to refer to this amorphous concept. They call it the real world. They call it the environment. They call it the data generating process, the hypothesis space, the problem domain. It's that place where the background knowledge is going to come from. It's the broader context. And then there are certain characteristics about societal context that we keep in mind. One is that it's messy. It's also qualitative and complex. It's causal and nonlinear. It's objective. It's dynamic. It's historical. These are all characteristics that don't align very well with the statistical methods that we use to build machine learning and AI systems. And so for that reason, we abstract away societal context. And a key assumption that we use to put up this abstraction boundary is the assumption that the random variables in the training data that we use to train the systems are independent and identically distributed, or IID. So this assumption, in a very oversimplified way, says that there aren't any causal relationships between the variables in the training data. There aren't any dependencies. So this goes against the very nature of the societal context that's generating this data. Remember, we said it's causal and it's complex. And when you ignore and abstract away societal context via that assumption, it's really easy to forget that once you're done building the model and the product, the inputs are no longer going to come from training data. They're going to come from inputs from the real world. And these inputs aren't going to obey that assumption. They're not going to obey that rule. They're not going to know about the IID assumption. So that's not going to hold. Additionally, the outputs are no longer going to live in the lab. Those outputs are going to become interventions on society. They're going to impact and change that societal context. And that's going to lead to a feedback loop that's going to impact the observations and data that are going to drive the next round of the development lifecycle. So you have this feedback loop that can become vicious if the inputs are not high quality in the beginning. If you make errors during that product development lifecycle, they can get amplified over and over again. The other thing that happens when we abstract away societal context is it leads to a lack of societal context knowledge on behalf of the product decision makers. They don't have knowledge about some of the key factors over in that societal context side because they've abstracted away. Now, folks who work in ML fairness have summed this issue up very well, what the impact is of abstracting away and having this lack of societal context knowledge. I'm going to read a quote from a paper written by a gentleman named Andrew Seltz, who's a thought leader in the machine learning fairness space. It comes from a great paper called Fairness and Abstraction in Social Technical Systems. I highly recommend everyone read it if they get the chance. It states that bedrock concepts in computer science, such as abstraction, render technical interventions ineffective, inaccurate, and sometimes dangerously misguided when they enter the societal context that surrounds decision-making systems. So that really sums up the impact that can result from abstracting away societal context. It kind of explains what could have happened to my mother. Now I'm going to introduce the problem understanding chasm because we think that's the root cause of us abstracting away that societal context. And I'm going to do it by talking about racial bias discovered in a medical algorithm that's widely used throughout the US healthcare system. This was a few years ago. The purpose of this algorithm was to identify patients with the most complex healthcare needs so that they could be given access to special programs. The idea being that this would reduce the cost in the overall healthcare system. But unfortunately, people not selected for the special programs by the algorithm suffered from nearly 50,000 more chronic diseases than those who were selected. And the people who were not selected were disproportionately Black Americans. This is why this algorithm was deemed to be racially biased. So what happened here? Why did this happen? The researchers who identified this racial bias had unprecedented access to every aspect of how this model was created. The training data, the machine learning architecture, the decision makers, all the evaluation results. And they determined that the root cause of this failure was incomplete problem understanding. And remember, problem understanding is at the very beginning of this life cycle. It's the key to being able to properly formulate the problems. And again, human decisions and choices drive this entire life cycle. So the decisions that humans make during these two phases are critical. and they can have serious downstream impact. And so it's important for us to really think about how humans make decisions if we want to solve this problem. So we took a look at how humans make decisions. We looked at the latest literature, and it says that when we make decisions as humans, we leverage our causal inference capabilities, and these are shaped by strong top-down prior knowledge in the form of intuitive theories. And we call these causal theories because of the relationship to causality. And these causal theories are models that we form in our head over time as we navigate complex realities to understand and solve the problems around us. These causal theories are our idea or our theories about why a problem is happening and what the key factors are. Now, let's take a look at what role causal theories played in the failure of that algorithm. So remember, the machine learning problem was to predict which patients would have the most complex healthcare needs in the future so they could be given access to special programs. Now, the causal theory that the decision makers who built the system leveraged was that more complex healthcare needs would lead to an increased spending on healthcare. And that prior knowledge, that causal theory, led them to decide to choose spending on healthcare as the target variable or the predictor or the proxy to predict complex healthcare needs. In other words, they said, if we can predict who's going to spend more on healthcare in the future, we can predict who's going to have more complex healthcare needs. And this is where the failure occurred, because this causal theory leaves out critical factors that impact how much Black Americans spend on healthcare, even when they have complex healthcare needs. These are factors like underdiagnosis due to bias, lack of trust in the healthcare system, wealth and income disparities, and lack of access to affordable healthcare. All these factors decrease how much Black Americans spend on healthcare. Again, even when they have more complex healthcare need. Now, those factors represent a subset of the structural inequities that exist in the US healthcare system. And those structural inequities actually increase how much complex healthcare need there is in the Black American community. And this was borne out through COVID. It revealed these structures. So those structures increase how much complex healthcare need there is, while simultaneously decreasing how much Black Americans spend on healthcare on average. So that causal theory that folks made decisions based on was woefully inadequate. It didn't include critical societal context knowledge. And this is because of this problem understanding chasm, this difference, this gap in understanding between civil society and product and tech. I want to show this in another form. Here's that problem understanding chasm. I want to show it as it relates to that product development lifecycle that I talked about. Because in order to bridge that chasm, we're going to have to solve this issue of societal context knowledge being able to make it across that chasm, right? To be available to these decision makers so they can make better choices. And so our hypothesis is that to bridge the problem understanding chasm responsibly, AI product developers need tools that put community validated structured societal context knowledge about complex societal problems at their fingertips, starting with problem understanding, but also throughout the entire product development lifecycle. Now, as we go about trying to solve this problem, we have to keep two key facts in mind. Number one, historically marginalized communities are disproportionately negatively impacted by harmful AI bias. And number two, the lived experience expertise of those same communities is usually excluded from that problem understanding and formulation process. So somehow we have to address these two key facts if we're going to be able to bridge the problem understanding chasm in a responsible way. So we think a key ingredient for bridging this chasm is participatory, non-extractive methods and capability to elicit community expertise about complex societal problems, and to be able to represent that as structured societal context knowledge. So this is where community-based system dynamics comes in. It is a method for prototyping problems and producing societal context knowledge. It's a participatory practice for centering communities in the process of understanding dynamic, complex problems as systems, using something called system dynamics, which was a method invented at MIT about 65 years ago. And system dynamics uses visual tools and simulations to support groups in collaboratively developing causal theories. So we also call these causal theories problem models or prototypes. And system dynamics leverages both qualitative and quantitative approaches. So this is a key aspect of system dynamics that's going to help us bridge this problem understanding chasm. Now, these simulations, as I said, are prototypes, and they're prototypes of the underlying systems and structures that cause the problem that we seek to understand and solve. And they can be used to actually test possible interventions on those problems in software before you try to do it in the real world, where it can be really risky. Now I'm going to walk through the basic visual notation that's used to prototype problems using system dynamics. There's two key visual representations. One is a causal loop representation, which is fully qualitative. And then there's a stock and flow representation, which is both qualitative and quantitative. I'm going to use a simple loan scenario model. So the sort of factors I'm going to talk about are average credit score, people defaulting on loans, people making payments. Now, the first key feature is a causal link. This is to indicate that our average credit score has a causal impact on loans received. When average credit score changes, it's going to result in a change in loans received. Now, these causal links, which are represented by a curved arrow, have either a plus sign or minus sign next to the arrowhead. And that plus or minus sign indicates what the direction of change is going to be as average credit score, for example, impacts loans received. So the plus sign means that that change is going to be in the same direction. So what that means is, as the average credit score goes up in this system, the number of loans received is also going to go up. But it also means as the average credit score goes down, the number of loans received is going to go down. So the change is in the same direction. If there's a minus sign on that arrowhead, it means that the change is going to be in the opposite direction. So in this system, if the number of loan defaults increases, the average credit score in this system is going to decrease as a result. If the number of loan defaults decreases, the average credit score is going to increase as a result. Now, the causal loop representation also lets you represent the fact that the result of an impact from one variable and another, the impact that borrowers has on loan defaults, it'll impact it, but sometimes it won't happen right away. There may be a time delay. So in this case, borrowers, as that goes up in the system, as there are more borrowers who have gotten loans, that's going to lead to an increase in loan defaults. But those loan defaults won't happen right away, right? It'll take 3 months, 6 months, 9 months before people start to default. And then the last key feature are feedback loops. There are two types of feedback loops: reinforcing feedback loops and balancing feedback loops. Reinforcing feedback loops are represented with an R with a loop around it. And a reinforcing feedback loop represents exponential growth in the system. And it tries to indicate which factors will contribute to exponential growth. So in this case, the combination of increase in borrowers who make their payments, which makes average credit score in the system go up, leads to more loans, and that can just keep on growing exponentially unless there's some sort of check and balance. So reinforcement feedback loop is an indicator of exponential growth. What are the key factors that are leading to that? A balancing feedback loop counteracts exponential growth. And so this feedback loop indicates the factors that can lead to balancing out exponential growth in this system. And in this case, it's a combination of borrowers. There are more borrowers that come into the system as more loans are given out. But as there are more borrowers, there are going to be more loan defaults, and that's going to lead to credit scores going down. At the same time that the credit score will have pressure to go up because of payments being made. So it counteracts or balances out that exponential growth. Now, the stock and flow representation has all the same features as the causal loop representation. You just represent them using these concepts of stock and flow. The key thing to point out is that stocks allow you to measure and keep track of accumulations of variables in a system. So as borrowers go up over time, you can keep track of that in terms of history. And then you can also represent the relationship between these factors mathematically. So this is the point where you start to add, mathematical relationships. An example of that, you can start to represent the relationship between variables using differential equations. And once you've done that, you're in a position to be able to simulate these causal theories. And the key thing about these causal theories or these prototypes is that they can represent societal context knowledge. That, the way average credit score is related to borrowers and defaults, that's a way to represent societal context knowledge. As you'll see, you can represent things like trust, et cetera, in these sorts of causal theories or problem prototypes. Now, I threw in this one demonstration of how you can look at the dynamics of a very simple model. This was built with a system called Loopy. It's a free tool that anybody can use to start to prototype problems. And if you want to take a picture of the URL, you can visit it a little bit later, but it just shows how these arrows impact how one factor impacts another. And it also shows a little bit about the accumulations, because as one factor impacts another, the credit score accumulates higher or lower, or loan defaults accumulate lower or higher. So now we have this method that we want to utilize to prototype problems, to produce societal context knowledge. But in order to do this responsibly, we have to build some community capability to prototype problems. This is to ensure that it's participatory and that it's non-extractive, that the community can benefit from producing this knowledge. So I'm going to just remind ourselves of that fact that I highlighted earlier. The lived experience expertise of historically marginalized communities is usually excluded from the problem understanding and formulation process. So when I started to work on this project back in 2017, I had that at the top of my mind. And so I wanted to intentionally form a partnership with a community-based organization from the beginning. And that turned out to be Data for Black Lives, which is an organization that consists of activists and organizers and mathematicians and scientists and data scientists, and they're committed to creating concrete and measurable change in the lives of Black people using data science. And so I wanted to start with that kind of organization as I started to think about this work. So I went to the first Data for Black Lives conference back in 2017, and that started a long 2.5-year journey of building trust and capability in system dynamics and prototyping problems. So as I said, I just went to the first conference, didn't have any preconceived ideas of what would happen. I just wanted to be with people, see what sorts of problems they were trying to contend with, see what challenges they were dealing with. And I discovered that there was this need, this desire for people to be able to see and understand the underlying systems and structures that generated the problems that they were trying to solve, that would help them see the interdependency between problems. And so I approached the founder of Data for Black Lives at the conference. I said, hey, you should let me put on a workshop at your next conference. She didn't know me from Adam, but after a little time, I was able to introduce her to CBSD, and she agreed to allow me to put on a workshop. We set a goal to conduct a community-based system dynamic workshop to build capability and capacity within the Data for Black Lives community at the next workshop, at the next community-based system dynamics at the next Data for Black Lives conference. We wanted to put on a CBSD workshop. And we also set a really important principle. And that was that the folks that were going to teach this workshop had to have similar lived experiences to the people who were going to be receiving the education. And unfortunately, the system dynamics world is not very diverse. So we had to create some system dynamics teachers to live by this principle. So the first thing we did is we put on a learning lab to teach the teachers community-based system dynamics. We pulled in people from the Data for Black Lives community, some folks from Google, taught them system dynamics, community-based system dynamics, so that they could teach the workshop at the next Data for Black Lives conference. They were able to achieve that in January 2019. They taught 75 members an introduction to CBSD. People picked this up very quickly. That went very well. So now we had some capability, and we had to decide how we were going to use it. So we decided to do a problem prototyping experiment around the health diagnosis domain. So this is another way to look at this problem, understanding chasm that exists between civil society and the product and tech world. We want to try to bridge that chasm. So we chose health diagnosis because on the civil society side, there is concern about health disparities and healthcare disparities, and that they're driven by underdiagnosis due to bias. Remember, this is one of the key factors that was left out or excluded when the decision makers formulated that causal theory, and that led to racial bias. So we wanted to look at underdiagnosis, and the product and the tech side. We're trying to build health diagnostic algorithms. We want those to work well for all groups. But in order to do that, you have to have diverse training data, which was a challenge, which was a problem. So we decided to jointly, prototype a problem. Let's go back here. We decided to jointly prototype a problem so that we can make progress in bridging this chasm to a shared understanding of a complex problem set. And so we were able to get some volunteers from the workshop attendees of that Data for Black Lives workshop that was held at the second conference. Had 9 folks sign up to help us, prototype a problem. And they created a causal loop diagram of the problem related to health diagnosis. I'm not going to walk through every element of this, but I just want to point out that one of the key factors that they highlighted and discovered was trust in medical care. And you can see that it is impacting multiple feedback loops in the system, both balancing and reinforcing. So it's an indicator of how critical that factor is. And remember, trust in medical care was another one of those factors that was excluded from the causal theory that led to the racial bias in that medical algorithm. They also created a stock and flow representation so that they could be able to simulate. This just shows where that structure of trust, how it impacts this overall stock and flow diagram. It's in multiple places, has a serious impact. So this factor of trust is really critical. And system dynamics gives you a way to actually qualitatively represent something like trust as well as quantitatively. And once you have that stock and flow representation, you can then simulate your problem and you can test interventions against that simulation. So this work ended up getting published in a paper that was accepted by the International System Dynamics Conference. Paper actually won an honorable mention award. You can check out this paper to get all the details on those models that were created, the data that was used, the simulation work that was done, and the interventions. Now, I learned a key lesson going through this journey of building trust and capability in system dynamics. It started off with, let's build some capability, but you can't do that without building trust first. And neither of them can be rushed. So you have to be patient. You have to make investments. You have to be in it for the long run. But that's going to be critical for us to be able to bridge the problem understanding chasm. We have to build this kind of capability and capacity in communities so that we can do this work in a participatory and non-extractive way. Now, to close, first, I just want to reiterate that key takeaway. And that is that interventions that ignore or abstract away societal context can lead to unattended and unnecessary harm. So again, if you don't recall anything else from this presentation, please remember that. And then finally, I'm going to throw out a few calls to action for those of you on the live stream. Number one, please spread the word about the problem understanding chasm and the impact that it can have. We need more people working on understanding the chasm and working to solve it. Number two, embrace the idea of prototyping problems as dynamic systems before you intervene with any kind of technology, but particularly AI, so that we can proactively mitigate harmful bias. And then finally, invest some of your time and energy. And if you're somebody who has access to dollars, invest that as well in building problem prototyping trust and capability with historically marginalized communities. And with that, I'll close, and I'm looking forward to the conversation.
Wonderful. Thanks so much for that really interesting talk, going through the different avenues, things that we should and must consider as we do this important work. So at this time, I believe somebody put a question in the chat, and people feel free to put questions or comments in the chat, or you can also use the Q&A button. I think we had a poll that was launched, and pretty soon it will pop up on my screen. If we can figure out how to close the poll so we can share the poll results. And there it goes. So first we asked, what is your status? If you're a currently enrolled student, 18% said yes, and then 82% graduated working professionals. And so we have some sophomores, seniors, master students, and we have For people who identified as female, about 57%, male, 43%. And then where do you currently live? 57% of us live in Georgia and 43% are outside of Georgia, but in the United States. So welcome and thank you for stopping by the wonderful city of Atlanta. And we had a question. What are your current feelings on the rise of artificial intelligence? Well, the highest rated one was the benefits outweighs the downsides. 54% selected that. And then next we have, it's a little scary. Yeah, I agree. And 14% said, I love everything about it. And 7% of us said, run, the robots are going to rule us soon. Okay, that we have seen that in movies. Yeah, one never knows. We also asked, what's a key source of harmful bias in AI systems that is often overlooked? The largest response, 36%, said data set selection. The next, that's followed by, well, actually tied with the training algorithm. And then next we have problem understanding and formulation. Then 11% said model architectural selection, and then 4% said evaluation metric choice. Really interesting discussion there. And I see, I'm going to go over here to the chat. I think people have put questions and comments on here. So I'll see if I can relay those questions to you, Donald. So first, someone said, so does that mean that race was not included in the algorithm?
Yeah, that's a good question. So yeah, race wasn't explicitly included in the algorithm, right? And so in the training data, and it wasn't considered explicitly in the algorithm. But as you can see, that doesn't really matter, right? Because of the context that the data itself doesn't have, right? And so we're relying on the people that are designing the system to have that contextual understanding so they can consider like, is this a good proxy for us to be able to try to predict complex healthcare need? And that knowledge was missing. And so I like the poll results. And one of the things I'm trying to emphasize is that a lot of people always choose training data, selecting training data. That's the key source of bias. But it starts earlier than that. It starts with the problem understanding and formulation, because that's the basis for which you select training data. And so I'm really trying to push people to pay more attention to the very beginning of this process. Before you select training data, you should be making sure you have a deep understanding of the problem. You should try to prototype that problem as a system so you can start to think about the context.
Yeah, because if you're trying to select, let's say, that training data, you could be selecting data that could be incomplete or may not be completely relevant if that contextual understanding isn't there. So how does one know they're selecting the right data or not? Or what are some strategies one could employ?
Yeah, that's a great question. I mean, one of another key issue is that sometimes we start these projects because we have some data, right? But until you do this process of understanding the problem, you don't necessarily know what data you need, right? And so there may be a key factor like trust in medical care, and you don't have any data about it. And so therefore, should you be trying to intervene on this problem with data science or machine learning if you don't have data about one of these critical factors? So that's why it's like start with that first step. And it's really important there's all this question of like, how do you know these models are right? The key thing though is not that they are right, but that they represent multiple perspectives of what these factors can be. And right now, we have people using implicit causal theories, which are not right or correct either, right? But we kind of trust that. And what we want to do is start to be explicit about what our causal theories are, about why a problem is happening and what the factors are, way before we start trying to apply data science or AI or ML. Because when you don't do that, that's when you have this real opportunity for bias to enter.
So true. So well said, Eric. I always say it's good to know what your, let's say, model can say, and it's also important to know what it cannot say.
Mm-hmm. Yes.
No data set is complete. And you're getting a lot of praise in the chat, and I agree. Somebody said, so good, wonderful presentation, very informative. And it's multiple people. So thanks everybody for that. And so somebody said, thanks for the presentation. It goes back to asking the right question. So really focusing on the problem you were trying to solve before diving in, right? We could have misguided hypothesis or investigation at the onset. And so they're saying, so yeah, starting with the right data set is key. And really creating those checks and balances. And math, sometimes we call those predictor corrector methods. There's an aspect in numerical analysis there where we predict something, but then we have something to correct. So it's kind of going along it's marching along where you're predicting and correcting.
Mm-hmm.
Almost in my mind is that same sort of spirit.
Yeah, what we're trying to do is have, the hypothesis before you predict, right? And these causal theories are the hypothesis about what the problem structure is, right? And then okay, now let's create a model that can do a prediction, but you want to be able to take that output and test it against your hypothesis in the beginning. And ideally, you would like to be able to kind of be able to do that experimentation in software, right? Even before you put something out in the world that might be harmful.
I agree. I mean, it's a beautiful, the way you said is beautifully said. It's the scientific method wrapped around data, where you start with that hypothesis. What do we want to investigate? We do some research, do background work, and test it out through data, and then, and march along that scientific method to really carry out what can we say, what can we not say, and communicating those findings. So yeah, super important. You also talked about this problem understanding chasm. And so, and oftentimes in the, we'll say in the healthcare field, for example, there is data and it's limited and people are making decisions on that. And sometimes we don't have these diverse perspectives really challenging and saying, well, what about that? I give you an example. I remember we went to a company, I won't call them out, and they looked at, let's say, African-Americans' affinity for having a physician who's also African-American. I said, well, some parts of the country that African-Americans may have an affinity for other demographic groups. Have you looked at that? And they were like, what are you talking about? So I won't go into the details of it, but just having those different considerations, that it's not just a one-dimensional aspect. So can you just share a bit about, and also you talked about the data for Black lives, really the need or the call for having, we'll say, diverse demographic groups ask these questions, maybe perhaps culturally relevant questions that really will drive this innovation forward. Can you comment on that?
Yeah, I mean, you point out a really key factor, and that's that you can't, look at a population and generalize. You have to look at subpopulations, right? And that's why it's so critical to have, as you said, a diverse set of perspectives that are participating in developing a initial causal theory or dynamic hypothesis about what's causing a problem. And so that's why we particularly use this thing called community-based system dynamics, because it's all focused on how you build capacity in on-the-ground communities so that they have agency over modeling these problems for their own purposes. That's the first thing. And then system dynamics itself, built into that is this idea of building a model as a group, because it recognizes that you have to have many different perspectives to try to see something from many angles for you to get even close to being able to represent, the quote unquote truth of it. But it's really trying to get close to reality. And even when people, and it's not about trying to get everyone to agree, right? It's trying to make explicit what people believe that system is, because what people believe that system is actually impacts how the system operates, right? Whether it's true or not, what I believe is part of the system and drives the dynamics. So that's why, figuring out how to have sessions where it's safe for people to be explicit about their perspectives on things is a key part of this. That can be tough. Sometimes you can't, because you want to get input from people you don't necessarily agree with, right? Because their opinions are part of this dynamic system. And if you don't represent them, you don't really have an understanding of the problem space. And so that's why I think efforts like data for Black lives is so important. But also, I think we're in this mode where we really need investment from, I think, starting off with like the philanthropic part of the world, right? Who are funding foundations and community-based organizations so we can build capacity and capability in these spaces. So we're getting many different perspectives from many different subpopulations from many different geographies.
Right. Yeah, I couldn't agree more. Somebody asked, could you share if the CVSD workshops are available?
Oh, that's a good question. So this is one of the challenges with this problem understanding chasm, is that there's not that much capacity and capability to put on these workshops, right? And we need to increase that. And so we're actually have done some work with Morehouse on trying to build that capacity at Morehouse so that they can facilitate and put on more workshops with communities so that even before anyone's thinking about data science or machine learning AI, the problems that communities care about, they can start modeling them and they can start producing knowledge that's going to be useful and available to both them as well as the people who are trying to intervene with technology. So that's why I'm really calling for people to invest time and energy, and if they have it, dollars, in building this capability. Really, we need to build it globally. It's not going to be a simple thing to do. It's going to take real intention and investment, but it's something that I believe that we have to tackle if we actually want to have responsible, robust machine learning AI systems being applied in these really high stakes domains.
Fantastic. And the person who wrote that is the amazing Professor Yvonne Phillips, also my classmate from Spelman, who facilitates workshops. And one of the workshops that she did, hopefully I can brag on her a little bit because she's awesome and amazing, so this past summer, she did a workshop on teaching data in the African diaspora so that participants can learn how to teach. It's a course, and she's really spearheaded the way on that. And so I'm just going to offer it out there that we'd be happy to host a workshop that would train folks, that would teach folks how to then go and lead these workshops. So you got the number.
Please connect us because I'd love to have a chat.
That would be cool. Super cool. Awesome. Yep. And she just put in the chat, happy to be a part of this. Yeah, she's fantastic. And then also somebody else said, well, what are your thoughts on how to estimate the harm and cost to marginalized communities when researchers / practitioners do not even understand the problem?
You're describing exactly why I'm trying to raise awareness about the problem understanding chasm, because that's the result of it. So, I mean, hopefully the talk kind of covered what I think about it. I think it's a big problem that doesn't get enough attention. We spend most of our time when we try to mitigate bias and harm in these systems at the end of the life cycle. When you're doing the evaluation of the model, now people are spending more time on choosing the training data, but you can't do a good job of that unless you have this deep understanding of the problem. But I think the reality is, in terms of how the real world works with respect to developing these products, we have to make it easy for people to incorporate the available knowledge during the typical workflows that they use to build these systems. I'd love for everyone to kind of read all the papers and read all the books and be experts in sociology, but in reality, that's not going to happen for these practitioners, right? So how do we come up with a source of knowledge that can be made available during these workflows, and to mitigate this issue of lack of understanding of societal context, lack of understanding of the problem before intervening with technology?
Wonderful. Somebody put in the chat, I'm a qualitative researcher and would love to add this skill and build capacity in my work with informaticians working on responsible use of AI in healthcare. And they would just love to learn more. So for those who want to learn more, where should they go? What should they do? What's the next step that one could take?
Yeah, I think so. So there's something called the International System Dynamics Society. So that's a place to go to get some initial resources on system dynamics, workshops, the practice. There's also a group at Washington University that is kind of one of the leaders on community-based system dynamics. And so I'd be happy for folks to, reach out to me on LinkedIn, and I can provide, some pointers to some of the places to go. But, my goal is it's good to hear this response, because ultimately we need, a coalition of folks that are interested, but then we need to be able to, the people interested, we need to be able to meet that interest with capacity and capability. So that's why we're out talking about this, so we can start a flywheel to get that kind of investment.
Wonderful. And I just put a link to your LinkedIn in the chat so people can connect, and you can look at Donald Martin, Google, LinkedIn, you can Google him and find him there. Donald, this has been really an informative discussion, really important. And the work that you do is very insightful and is needed, and we all take a bit of ownership in being responsible in AI, because it really does, as you have demonstrated today, it does impact our lives and the lives of our loved ones and everyone else. So thank you, Donald, for hanging out with us in our seminar series today. Really appreciate it. And thanks everybody for coming. I hope everybody has a great rest of their day.
Thanks, everybody. It was an honor and a pleasure. Thanks, Talitha.
Fantastic. Thanks so much.